Hi students, in the previous video we discussed about litmus paper test. Okay, acidic substances can change blue litmus paper into red color, whereas basic substances can change red litmus into blue color. So after that we discussed some of the bases like magnesium hydroxide, potassium hydroxide, sodium hydroxide. We tested the litmus paper and they were changing the red litmus paper into blue color. Okay, and bases are so quick to touch and they can change the red litmus paper into blue color. So that was the part we discussed. So today we will discuss about chemical indicators. So here litmus paper also indicator, turmeric also indicator. So in addition to those indicators, we will discuss another indicator, the chemical indicators. The chemical indicators are chemical indicators. So indicator is a substance, it can indicate whether it is acid or base by changing its color. So chemical indicators are methyl orange, and phenolphthalein. So methyl orange and phenolphthalein. These two are called as chemical indicators. These two are examples for chemical indicators. Now, how they will change their colors in acids and bases? How can you distinguish or how can you classify the acids and bases by using these two chemical indicators? Okay. So now let us do 6. Let us do 6. By using these chemical indicators, how can you classify the acids and bases? Now see here, so take the substances that are given in the table 3 and test them with phenolphthalein and methyl orange solution. Take a small amount of these substances in 2 test tubes, add a few drops of phenolphthalein and methyl orange to each test tube separately. Note down the effects and repeat this process for all the substances one by one. Draw a table just like table 7 in your notebook. Okay, so the table 3, so many samples we observe. That samples we need to take, and each and every sample we need to add phenolphthalein and methyl orange, and we need to note down the color changes. Okay, so the substances what we have taken in table 3, all those samples once again we need to test with the methyl orange and phenolphthalein. Methyl orange and phenolphthalein. Those results, those color changes, we need to record in table 7. Okay, so table 7 is there. Some examples I will take and I will do the color changes. Now see here. So substance. It's a simple table. Substance. Next, colorless phenolphthalein. And methyl orange. Okay, so the table with so many substances are there. I will take some examples. I will give the hint by taking acids, two examples of acids and two examples of bases. I will give the color change. Based on that, you need to record your observations by the samples taken in table 3. Okay. Now see here, I am taking examples as hydrochloric acid, sulfuric acid, sodium hydroxide, potassium hydroxide. These are the samples around the examples. Okay. Now, test the hydrochloric acid with the phenolphthalein indicator. Okay. So, phenolphthalein remains colorless in hydrochloric acid. Phenolphthalein remains colorless in hydrochloric acid, whereas it changes into red color with methyl orange. With the methyl orange. First take the color only phenolphthalein indicator. Afterwards we will go for the methyl orange. So whenever you test the hydrochloric acid with phenolphthalein indicator, okay, if you take the sum of the amount of hydrochloric acid and if you add phenolphthalein into the hydrochloric acid, it remains colorless. At the same time, if you add phenolphthalein to the sulfuric acid, it is also colorless. It is also colorless. Okay. So next step, if you add phenolphthalein to the sodium hydroxide, it turns pink or red color. Pink or red color. At the same time, if you add phenolphthalein to this potassium hydroxide, it is also changing pink or red color. Next, if you add methyl orange to the sulfuric acid, it changes into red color. And if you add methyl orange to the sodium hydroxide, it changes into yellow color. At the same way, if you add methyl orange to potassium hydroxide, it changes yellow color. So these are the color changes when you test these samples with phenolphthalein and methyl orange. These two are chemical indicators. Okay. So next is of the table some questions are there. What can you conclude from the above data? Keep in mind that some substances are acidic, some are basic, and some are neutral. Okay, so neutral substances I not take here. While you are doing it, the sample table is the samples are there. Okay. Next here. So compare the above observations. Those are the case of litmus test. Litmus test. So these observations we need to compare with the litmus test. So litmus test, acid, blue litmus changes to red color, isn't it? Base, red litmus changes into blue color. These observations we need to compare with these color changes. Now, can you distinguish the acids and bases using indicators? Yes. By using indicators only, we can distinguish acids and bases. What would be the criteria for deciding this? What would be the criteria here? Color changes. By using indicators, by the color changes, we can decide whether the substance belongs to acid or base. Now, from the table, we can conclude that methyl orange gives red color with acids. These two are acids, that you know. Methyl orange gives red color with acids, whereas phenolphthalein remains colorless in acids. Okay, next methyl orange gives yellow color with bases, whereas phenolphthalein gives pink or red color with bases. That is the overall conclusion, and this is important. How phenolphthalein and methyl orange gives different colors with acids and bases. This is important point. Methyl orange gives red color with acids, red color with acids, and yellow color with bases. Yellow color with bases. Phenolphthalein remains colorless in acidic solution. While it turns pink in basic solution. Pink or red in basic solution. Basic solution. Okay, so this is important. From this table, what we need to conclude here? Methyl orange gives red color with acids and yellow color with bases. Phenolphthalein remains colorless in acids, and phenolphthalein gives pink or red color with bases. So based on this data, you know in table 3 which are acids and which are bases. Which are acids and which are bases. Which are acids and which are bases. For acids, phenolphthalein, this type of color changes we need to note down, and bases, this kind of color changes we need to note down for the phenolphthalein. For the methyl orange, for acids, this kinds of color changes, bases, this kind of color changes. Like that, complete the table 3 in table 7 by using phenolphthalein and methyl orange as indicators. Okay, next step. So, color changes you need to remember, that is important. Now, a small concept was given to you. Do you believe that blood comes out from a lemon? How is it possible? Do you believe? Is it possible? The blood comes out from the lemon? So it is possible. That is not blood. A red color liquid comes out from the lemon, but it is not a blood. So when a magician or a juggler cuts a lemon, blood flows of it. Actually, he uses a knife that was dipped into the methyl orange solution. Okay, so whenever the knife was dipped into the methyl orange solution, whenever cut the lemon, so generally lemon is an acidic solution. So whenever the methyl orange applied knife cut the lemon, that acid mixes with the methyl orange, it changes into a red color. That red color liquid comes out as a blood. They will say that is blood. That is actually that is not a blood. That is a magic there. What they will do? They will dip the knife into the methyl orange solution and they will cut the lemon. So while methyl orange mixed with the acids, it changes into red color. So that red color liquid flows from the lemon, and that is, they are saying that is blood. That is not correct. That is not blood. Just it is a methyl orange. When it touches the acids, it will change into red color. Okay, what actually happening there? So when methyl orange mixes with acids, citric acid, generally lemon consists of citric acid, natural acid. Citric acid, lemon juice, it turns red, but it is not blood. In many of our places, we find people doing this and presenting it as magic. In our state, some are performing above science tips as black magic. Black magic means mantra, so mantra, charpadi and panamiti, all these are not correct. And these are people now, you can also do this one. You can also do this one. Simply taking some methyl orange, dip into the you need to dip the knife into the methyl orange solution. If you cut the lemon, again you will find a red liquid comes out from the lemon. So this is the magic they are doing. Generally, actually that is not black. Just with the methyl orange and citric acid mix. If you mix the methyl orange and acid, what happens? It will give red color. Okay. So next, let us do some experiments. Let us do some experiments. So take a natural acid, say lemon juice. We are taking a natural acid. That is lemon juice. Okay. Now, so lemon juice we are taking in 6 test tubes. Lemon juice. This is lemon juice, and we are adding copper, zinc, magnesium, iron, brass, aluminum pieces into each of the test tube. Copper, zinc, magnesium, iron, brass, aluminum. Okay, we are taking lemon juice and we are adding the metals which are copper, zinc, magnesium, iron, brass, aluminum pieces in each of the test tube. Note down your observation. This is brass, not a metal. Okay, so whenever metal were added to the acids, they can form metallic salt and hydrogen gas. This is important reaction. Whenever metals were mixed into the acids, it form metallic salt and hydrogen gases. Some of the metals they cannot form the hydrogen gas, so that you will learn in the next chapter. By the reactivity series we can decide that one. Okay, so some of the metals they cannot release the hydrogen gases, so that will be discussed in the next chapter, that is types of chemical reactions. But the general equation is metal plus acid is raised to metallic salt plus hydrogen, except this remaining all metals. So in this experiment what we need to conclude, whenever metals were added to the acids, generally they can release the hydrogen gas. They can release hydrogen gas. What is your observation, they asked there? What is your observation? So that observation, some gas was released. The gas is released. Which kind of gas it is? What is the gas it was? We need to test that gas. So now, light a mastic and introduce into the test tube. What do you observe? Okay, so any one of the test tube we need to take. This is acid, for example, let us consider we are adding zinc to it. In the case of this one, acid plus zinc. So, zinc salt and hydrogen gas. Hydrogen gas is released. So, how can you test the hydrogen gas? So, if you introduce a burning mastic, let us consider it as a burning mastic. It is a burning mastic. If you introduce the burning mastic into the test tube, it catches fire with pop sound. It catches fire with the pop sound. So, from that we can conclude that the released gas was hydrogen gas. How can you test the hydrogen gas? If you introduce a burning mastic into the test tube, it catches fire with pop sound. Then we can say that hydrogen gas was released during these experiments. In all the experiments, metal plus acid. Acid not a metal, it is an alloy. So except these remaining cases, hydrogen gas was released. Okay. So copper substance was not produced. So that will be discussed in the next chapter. Okay. So why it was not producing that was discussed in the next lesson. So apart from that, generally metals mixed with acids they form metallic salt and hydrogen gas. So how can you say that the released gas is hydrogen? We need to test with the hydrogen gas. So when you introduce a burning mastic into the test tube, what happens? It catches fire with the pop sound. So that is the test for the hydrogen gas. Now we can say that the released gas is hydrogen gas. So Henry Cavendish, an Italian scientist, discovered a colorless gas called hydrogen. Okay, so this gas was used to fill the balloons, and these balloons are used for beautifications. This is for decorative material. And weather observation balloons also generally they fill with hydrogen gas. Why? Because hydrogen is lighter in weight. That's why it can move heights in the sky. That's why it will be used in the weather observation balloons or in the beautifications. So the gas, hydrogen gas, was discovered by an Italian scientist, Henry Cavendish. Okay. Next, this reaction is important. Metal plus acid is equals to metallic salt plus hydrogen gas. Next, a small column is there. Do you know why the inner sides of the vessels made up of brass and copper coated? This is important question. Why are the inner sides? Why are the inner sides of vessels made up of So why are the inner sides of the vessels made of brass and copper coating? This is an important question. Once see this one. When some substances are kept in a copper container for a long time, then a blue-green layer is formed in the inner walls of the container. What is the reason for that? Means copper reacts with the acids present in the substance and forms a blue-green compound. Okay. So whenever the foodstuff preserved in a copper vessel for a long time, generally foodstuff contains some acids. Those acids can react with the copper. So by the reaction between the acids present in the foodstuff with the copper, it forms a blue-green layer. Okay, blue-green compound. So to avoid this reaction, the inner walls of the vessels are coated with tin. So generally, if they are not coated with the tin, what happens? The copper reacts with the acids which are present in the foodstuff. They form blue-green compound. To avoid this one, copper vessels are coated with the tin. So copper vessels inside coated with the tin. The tin can prevent the reaction between copper and the acids. So tin does not react with the acids. Okay, so that's why the copper vessels are coated with the tin inside. Okay, the page number 14 is there, that is important. Next, why are the pickles, jams and jellies preserved in glass or porcelain and plastic containers? This is important one. What is the question there? Why are the pickles, jams, jellies preserved in glass, porcelain and plastic containers? If the pickles were stored in metal containers, so metals react with acids, and what happens? Pickles may spoil. Why they are spoiling? Metals easily react with acids. If the pickle contains, most of the part of the pickle contains acids. If you store the pickles in metal containers, easily they will react and the pickle will be spoiled. If you store the pickles in glass or porcelain containers, they do not react with acids. Glass or porcelain, they do not react with the acids. That's why they do not get damaged. Okay. Why are pickles, jams, jellies preserved in glass, porcelain, and plastic containers. Okay, so the answer is generally acids do not react with plastic, glass and porcelain containers. Okay, simply you can write it. If they are stored with metal containers, acids can easily react with the metals. To prevent that reaction, they can preserve in glass, porcelain and plastic containers. Simply this glass, porcelain and plastic containers do not react with pickles. anchovies. Simply you can write this. If they store in the metal container, they will easily react and they may get spoiled. Simply you can write that answer. So don't try to complete please try to complete homework and send it to me. And in the next video we will see some more experiments. Thank you. The remaining part will be discussed in the next video.